Time to throw out some of your old middle school geography textbooks. Throw out some of your old middle school geography textbooks.
Eldridge Moore is a UC Davis geologist, says earthquake science is in its infancy.
Ever since the 1906 earthquake, every earthquake that's occurred in California has been unexpected. It's been on a fault that either people didn't know about or they didn't expect to move in the way that it did. So we have a lot to learn yet about where faults are. So we have a lot to learn yet about where faults are.
About how we got here from Pangaea.
In the late 16th century, Abraham Ortelius, in compiling New World Explorer maps, noted that by carefully considering the coastlines of the Atlantic Ocean, it appeared that the Americas had been torn away from Europe and Africa by, he theorized, earthquakes and floods. Earthquakes and floods.
You're a little bit more creative, there are other parts of the world that you can kind of start to see how they might have fit in with each other in the past. And that, that by itself, that's just a very small clue, but it kind of hints at, well, maybe if they at one time were next to each other, or if this was kind of connected, then they've had to moved apart at some time. Although it doesn't tell us that it's still moving or what might have caused the movement. And it definitely doesn't definitively tell us that they even moved. Maybe this is just a coincidence.
As a matter of fact, think with me for a moment. Since the Roman times, 2,000 years ago, the English North Sea coast has eroded 2 miles west along the east coast of England. We know of 35 villages in the Roman census 2,000 years ago that have been completely lost into the sea. That's an average of 5 foot per year. Clearly, that erosion rate, cannot have been going on for millions and millions of years. Is that right? There simply wouldn't be in England.
Over the next 3 centuries, other proponents of an original single continent included Francois Paget, who invoked the sinking of the land between the continents to create the Atlantic Ocean, Georges-Louis Leclerc, who resurrected Ortelius's theory of a great earthquake and floods pushing the land apart, and finally Antonio Snider Pellegrini, who proposed that the shape of the continents, supported by fossil evidence, argued for the origin of a single continent, which not only joined the continents across the Atlantic Ocean, but also included Australia.
So we have a lot to learn yet.
Throw out some of your old middle school geography textbooks.
Earth. A unique planet. Restless and dynamic. Continents shift and clash. Volcanoes erupt. Titanic forces that are constantly at work, leaving behind a trail of geological mysteries. One of Earth's most intriguing mysteries is the presence of a huge arc of geological destruction surrounding the Pacific. Huge arc, huge arc. It is known as the Ring of Fire. August 1883. Indonesia. The Krakatoa volcano blew itself to pieces, creating the loudest sound in recorded history. June 1991. The Philippines. Mount Pinatubo blasted debris, 22 miles into the atmosphere. Suffocating ash, swamped over 2,500 square miles. And in May, 1980, Mount St. Helens caused $1 billion of damage. The ever-present threat from these volcanoes makes it essential for scientists to understand the forces that power them. The investigation begins here, in Alaska. This land of rugged beauty marks the most northern extreme of the Ring of Fire. 75% of all the volcanoes in the United States are situated in Alaska, making it a perfect laboratory for volcanologists. The first step is to discover how the Ring of Fire's giant volcanoes form.
We're headed to Augustine Volcano, which lies in Cook Inlet, and it's part of the chain of volcanoes that extends all the way down into the Aleutian Islands.
It's a 60-mile journey out across the frigid Alaskan water. In the distance, the volcano soon appears.
There's Augustine Volcano over there. It's going to be a perfect day to visit.
From high above the clouds, Dr. Bull can gain a clear view of the volcano's distinctive outline. Augustine is a stratovolcano, the type of volcano found all around the Ring of Fire.
Stratovolcanoes are quite unique, in that they are shaped as beautiful cones, and Augustine is a perfect example of that.
Augustine last exploded in January 2006. The most recent of 7 eruptions here since 1935. Over the years, solidified lava flows have gradually built up on the volcano's flanks. To investigate what makes these volcanoes so dangerous, Dr. Bull climbs high up on the side of one of these lava flows.
This lava is made up of blocks. There's bits that are little denser than others, and you can see there's a lot of different pieces to it. So we call this a blocky lava flow.
This blocky lava provides a crucial clue as to why the Ring of Fire volcanoes can be so deadly.
This lava is more thick when it comes out of the volcano, and its thickness will have an effect on how it runs down the slope. The thickness or viscosity of lavas can be shown in a number of ways. Hawaii lavas are quite runny. Honey is a perfect example of that. If you have a volcano putting out Hawaii-like lava, it's going to run quite easily down the rock. Whereas if you have something more like these blocky lavas, they're going to be a little bit more like peanut butter. They'll still run, but the viscosity is much greater.
The viscosity of lava is primarily determined by the amount of silica it contains. Silica is the most abundant mineral in Earth's crust.
The more silica, the thicker or more viscous the lava is likely to be.
Hawaiian lava contains little silica, so it's runny, and produces a relatively flat landscape. But Ring of Fire lavas are rich in silica, making them sticky and less able to flow, creating tall, cone-shaped stratovolcanoes. During the 2006 eruption of Augustine, thermal imaging cameras were used to study the volcano. They showed this sticky lava building up, layer upon layer. But the thickness of this lava also makes these volcanoes lethal.
Because these volcanoes have lava that is thick, things don't move through them very well, and bubbles of gases can build up.
Deep in the earth, under immense pressure, molten rock called magma contains dissolved gas, but as this magma rises, the pressure decreases. This drop in pressure means bubbles of the gas begin to appear, just like opening a bottle of soda. If the magma is runny, these gases can safely escape. But in sticky, silica-rich, Ring of Fire magma, the gases can get trapped, often with terrible consequences.
It's like trying to have a bubble move through peanut butter. It won't happen quite so easily, so there's a lot of pressure that builds up, and once that pressure builds up, it reaches a point where it can't take all that pressure anymore.
The result, giant explosions caused by the catastrophic buildup of gas inside the molten rock. This is the reason Ring of Fire volcanoes can be so dangerous. But it's not usually the initial explosion that kills, it's what happens next.
Those explosive eruptions can create plumes that go up for tens of miles.
When these plumes run out of energy, they can collapse back down the sides of the volcano, in a superheated avalanche of ash and gas. With temperatures of 1300 degrees Fahrenheit and speeds over 100 miles per hour, these flows destroy everything in their path. A terrifying consequence of the explosive eruptions caused by gases building up inside thick lava. In the next stage of her investigation, Dr. Bull searches for clues as to how this sticky lava forms. On Augustine's lower slopes, she hunts for lava samples from inside the volcano. This giant block of solidified sticky lava was once molten magma, deep underground. It was blasted out here during an eruption, and it came with some intriguing evidence.
So, what I'm seeing in this rock is a lot of minerals, and a little bit in some cases of hornblende.
The presence of these hornblende crystals provides a crucial clue to how the magma formed.
This is important in telling us something about magma conditions, where the hornblende crystallized. Hornblende is a mineral that only forms in the presence of water.
These hornblendes show water exist, deep in the earth. Deep in the earth. Scientists suspect this water plays a crucial role in creating the magma that powers volcanoes. Deep underground, rocks are hot and semi-solid. It might seem that the presence of water would cool them down, but that's not what happens. This water, which is under huge pressure, alters the rock's structure and causes them to melt, forming plumes of magma. This molten rock soars up to the surface, building giant volcanoes. Without water causing magma formation deep underground, these ring of fire volcanoes would simply not exist.
A lot of this process we're still working on and we don't understand, but there's a fair amount of it that we do, and water has a very significant role in when and how rocks melt.
The investigation into why the ring of fire is so dangerous has uncovered two important pieces of evidence. Blocky lava flows are evidence of thick, viscous magma which traps gases inside volcanoes, leading to explosive eruptions. And hornblende crystals reveal that water, deep underground, encourages the formation of the magma that powers the volcanoes. The geology detectives figure out how this water gets underground, and make a remarkable discovery: the chemical signature of microscopic organisms inside the volcanoes. All around the ring of fire, explosive magma is forming deep underground, fueled by water. Solving the mystery of where this water comes from is the key to how scientists will figure out why the ring of fire is so dangerous.
Scientists have looked long and hard into the origins of Earth's water, and what they've found is amazing. Our planet shouldn't be wet at all.
Why?
The place where the Earth is right now seems very dry. So if the Earth formed as a dry rock around a hot young star, then how did this water get here?
Every possibility has problems. Every possibility has problems.
The investigation now turns to Mount Lassen, an active volcano in Northern California. Surrounding the volcano are bubbling hot springs, boiling mud, and volcanic vents called fumaroles, belching superheated steam and gas. All this thermal activity is driven by the immense heat rising from magma deep underground. By sampling the gas coming from these fumaroles, scientists hope to discover the source of the water which causes the magma to form. This device measures the temperature. The temperature of this fumarole is about 200 degrees Fahrenheit. So just about at the boiling point for this elevation. And that's what we want for a good gas sample, a good boiling fumarole. So you can see what's happening at the surface here, all this steam coming out of the ground. But it's the gases that are along with the steam that we look at closely. And the composition of those gases tell us about what's happening at various depths beneath the ground where we can't see. Tests on these gases, collected from volcanoes all around the Pacific Ring of Fire, have revealed something surprising. The gases contain carbon-12, a type of carbon that comes from living organisms. The specific levels of C12 found here are the unique signature of tiny sea organisms called phytoplankton. Billions of phytoplankton live in the ocean. As they grow, they absorb carbon-12 into their cells. When they die, they fall to the bottom, forming layers of sediment. In this way, their carbon-12 is transferred to the seafloor. Intriguingly, scientists have found this same carbon-12 pouring out of volcanoes all around the Ring of Fire. Volcanoes of the Cascade Range have carbon dioxide that's very rich in carbon-12, and it's almost like you're cooking oceanic sediments that are rich in phytoplankton down deep beneath these volcanoes to generate the carbon dioxide you see coming out the top. That links this carbon dioxide to organic sediments way offshore in the ocean. The organic matter that was originally phytoplankton becomes carbon dioxide that we see at the surface. Seafloor sediments are getting into volcanoes. and these sediments contain seawater. This is the water that causes the rocks to melt below the volcanoes, forming magma. But a mystery remains. The magma plumes feeding the volcanoes lie sometimes hundreds of miles from the ocean. The scientists now have to figure out how the sediments loaded with seawater are moving so far inland. To find out, the investigation heads for Alaska's Chugach Mountains. The research here begins with an analysis of the local rocks. Oh, this is a really neat boulder that's right here. And what you can see in it is that there's this whole mixture of rock types. You can see that there's this black stuff which would originally have been mud. There's several different colors of kind of greenish rocks which would be kind of different flavors of volcanics. Oh, here it looks like there's limestone, and I'm gonna put some acid here. And if it fizzes, it's limestone. Yeah, sure enough that's what it is. And this would have formed in the ocean. And so this is made up of the bodies of little critters that got incorporated into this rock, and now it's up here in the Chugach Mountains. The presence of jumbled oceanic rocks 20 miles from the sea is evidence that something remarkable is happening at the bottom of the ocean. Geologists know that only an enormous process called subduction could shift these mixed ocean sediments here. Subduction occurs when the seafloor moves and slides down under the land. As it descends, the top sediment layers are scraped off by the land like a snowplow scoops up snow. They're pushed up into a huge mound of mixed up rocks. The Chugach Mountains were formed in this way. The seafloor, loaded with water, now continues down into the earth. This is how seawater gets deep underground, where it creates the magma plumes that build the Ring of Fire's explosive volcanoes. Where we're at right now, the Pacific is subducting beneath us to the northwest at this northern part of the Ring of Fire. It's about 20 miles beneath our feet right here, but if we were to go off that way where the volcanoes are, it's about, and so as it goes to the northwest, it subducts and then brings water and sediment into the earth that ends up causing melting in the mantle, and then that melt rises as magma to volcanoes. The investigation to discover how water is getting down below Ring of Fire volcanoes has turned up intriguing clues. Carbon-12 samples indicating fat ocean sediments are getting deep below the Ring of Fire's volcanoes, and mixed rocks in the Chugach Mountains are evidence that the whole seafloor is on the move, sliding deep under the land. This process is the engine that powers the Ring of Fire's killer volcanoes. But deep underground, the Ring of Fire hides another even more deadly secret. Earthquakes, that can destroy entire cities. The Ring of Fire, a lethal line of volcanoes, 75% of all the volcanoes on the planet. These fiery peaks encircling the Pacific Ocean are built by tremendous forces deep in the earth. Eruptions here have taken many thousands of lives and destroyed billions of dollars of property. But an even bigger killer is present on the Ring of Fire. Earthquakes. 90% of the world's quakes occur in this narrow band around the Pacific. often with disastrous results. Sumatra, September 2009. A giant earthquake left more than 1,000 people dead. Mexico, September 1985. More than 9,000 people were killed by a massive, magnitude 8 quake that shook Mexico City. And Alaska, March 1964, North America's greatest ever recorded earthquake, near Anchorage. This quake was so powerful, ground movements were observed 4,000 miles away in Florida. Such awesome power drives scientists on to discover why these deadly quakes occur all around the Ring of Fire. The investigation moves to Prince William Sound, 36 miles from the epicenter of the 1964 Alaskan disaster. We're at the northern edge of the Ring of Fire, and we're gonna be looking at evidence for how geologically active this area is today. Hausler heads for Montague Island, a place that's permanently scarred by the powerful forces which shape this entire region. On land, he finds a rugged boulder-strewn shoreline. So you can see we're at the edge of the ocean. We're in a high-energy environment. There's boulders all over the place, and we're at the top of the beach. Waves have been crashing here and basically getting rid of the little tiny rocks, leaving only boulders behind. And then right here, you can see that these boulders are kind of lined up against each other like dominoes. And so it takes big waves to sort of flip these over and line them up kind of like dominoes, like that right here. But it's not this rocky beach that reveals how violent Ring of Fire quakes can be. The real evidence lies 1/4 of a mile inland. Hausler hunts through the thick undergrowth. Hidden by the trees is a near identical line of boulders. We've hiked in, thrashed through the alders, the Alaskan jungle up to here. We're probably 25 or 30 feet above sea level at this point, and what we have here is a beach. I mean, this is basically a perfectly preserved high-energy beach environment like we were looking at down on the shoreline. And you can see here once again there is these big boulders that are sort of laid over in this domino-like fashion, sort of pointing uphill as a result of this big wave energy, big waves pounding on the beach flipping the boulders over, pointing in the uphill direction. This inland raised shoreline runs for hundreds of yards parallel with the ocean. It's a key piece of evidence. And it can only mean one thing: the land itself must have recently risen up out of the ocean, taking the entire shoreline with it. It means that there was an event that was essentially an instant in which this region was uplifted to this elevation and made this here. This has to have been a result of a big earthquake. Really cool. What we're looking at here is a result of the 1964 Great Alaska Earthquake. Pretty much right here where we're at is where there was the largest uplift that occurred. So we know from this kind of earthquake that occurred here in a thrust-type earthquake, or even there was a fancy term, megathrust earthquake, because it was so big that occurred right here. And this is a result of the slippage of one piece of rock over another, or one underneath the other.
Or they didn't expect to move in the way that it did.
Megathrust quakes like this are the most powerful on Earth and are one of the great dangers of the Ring of Fire. If they occur under the ocean, they can generate killer waves called tsunamis. High on the hillside lies West Seismic Station, protected under the yellow cover from the elements and the local bears. Several thousand seismic stations like this exist, all the way from Alaska down to California. This whole system together monitors any kind of seismic activity, any sort of earthquakes throughout this whole area. It's part of a whole network on all of the volcanoes around here, on the mainland, and throughout this whole area. So the seismic data can be used not only to judge the severity of the earthquake or the magnitude, but also when taken across a number of stations to pinpoint the location of that earthquake. In Alaska, we're looking at about 1,500 earthquakes every month. And you take all of those together, and you start to see patterns. They map out a ribbon of earthquake activity that follows all along the coast. This ribbon of earthquake activity extends all around the Ring of Fire. But it is what scientists can see below the surface that is most revealing. If you look at it from the side, you see that actually the earthquakes that are happening close to the ocean tend to be shallow, but as you go inland, they're deeper and they create this dipping feature that starts out in the ocean and then dips down beneath the continent. This giant dipping feature provides conclusive evidence for how the megathrust earthquakes are generated.
Time to throw out some of your old middle school geography textbooks. Since its primordial days, Earth's surface has been on the move, shifting and changing the look of its skin slowly through a process known as plate tectonics. But new research questions long-held theories about how our rocky surface floats on a molten and convecting mantle that drives continental migration. By studying the dynamics of seismic waves traveling through the boundary between the hot, viscous layer known as the asthenosphere and the rigid, cold crust, the lithosphere, scientists have concluded that the melted mantle doesn't blanket areas of the globe enough to be the only thing moving massive plates. They say other factors, such as water and mineral grain size, may be conspiring to aid in plate movement as well. Sorry,
liquid hot magma.
You may no longer get all the credit.
There are ridges, outcrops, canyons, gullies, mountains underwater. And so the ability to make a continuous map of the sea floor, get a full picture of it, gives you the ability to understand how the seafloor is put together and what it has to do with the way the Earth functions.
Reynolds is using high-tech, echo-sounding technology to monitor the exact depth of the seafloor. A sound wave is sent from beneath the ship. The time it takes to reach the seafloor and return gives an accurate reading of depth. Reynolds' research shows that all around the Alaskan coast, the seabed is relatively shallow. But farther out towards the open ocean, the readings change dramatically.
So in general around the world, when you go out from land, you cross over a relatively flat shelf, down the slope, and into the deep ocean basin, which is very flat, which is very flat, which is very flat, which is very flat. But around the Ring of Fire, as you go out from land across the shelf, down the slope, instead of going directly into a flat ocean basin, you go across a very deep trench. These trenches are the deepest areas on the planet, and the one around Alaska reaches approximately 21,000 feet.
These giant features are called subduction trenches. The largest are deep enough to swallow all of Mount Everest. But the investigation isn't finished. Experts journey to Tiger Mountain in Washington state to figure out how such huge plates can be shifted against each other. The GPS that you use to drive around can tell you where you're at on a city block or on a street to within a meter or so. But in geology, we're interested in centimeter to millimeter accuracy so that we can track the changing of the land. It's much more subtle. Here we are on Tiger Mountain. This is our GPS unit. What we have is these metal rods going into solid bedrock, cemented in so that there's no motion. This GPS antenna allows us to measure point positions per day of where this spot is. A network of these GPS antennas across North America provides evidence for the monumental forces which power the Ring of Fire. This is just a single antenna. There's hundreds all across the western United States to give us a better picture of what's going on with the ground surface. By combining all the data of these GPS, we're able to see that North America is actually moving. The entire continent is moving westwards at about 3 inches per year. This movement is possible because the Earth's crust rides upon a hot, soft layer of rock called the mantle. Well, the mantle is so hot and at such a high pressure, and the temperature is hotter as you get towards the center of the Earth, that's gonna want to move out and convect just like a boiling pot of water. And so it creates a convection current coming up to the surface which then drags along those plates on top. These phenomenal convection currents force the Pacific Plate into its neighbors, driving the process of subduction. This, is the real story of the Ring of Fire.
Many simply call it a myth. Fewer and fewer these days believe the flood account from Genesis 6 to 9 is actual history. The Bible frames the flood as an actual historical event, one that involved a specific family of 8. Genesis says the flood lasted for a full year, engulfed the entire world, and preserved animals, plants, and humanity from well-deserved judgment. The flood represents the most detailed account of any single event in the Bible. Over 1,800 oil well boreholes from 4 continents have all been compiled and mapped. The newly emerging map tracks the thickness and extent of each rock type as they were laid down by the flood. This research reveals the same 6 megasequences of sedimentary rock layers across multiple continents. Each megasequence contains a huge stack of rock layers, often with coarse-grained sandstone on the bottom, then finer-grained deposits like shale, then topped by limestones. Each megasequence is bounded above and below by flat, eroded surfaces called unconformities. A few places on Earth have layers that represent all 6 megasequences.
But this is my claim that plate tectonics is false and it's just a lie. And I'm going to prove it with science, and I'm going to prove it with Brian Cox. If you're familiar with him, I'm going to play the video and I'm going to question what he just said.
Around 2,500 years ago, a civilization we know almost nothing about built this fortified temple in the desert. Its walls were once brilliant white and covered with painted figures. Today, all but the smallest fragments of the decorations are gone. The details of this culture and all traces of its language are lost. And yet, if you stand in the right place, you can still experience the true purpose of Shankio in just the same way as you could the day it was built. But to do that, you have to be here before the sun rises. These towers form an ancient solar calendar. Now, at different times of year, the sunrise point is at a different place on the horizon. Actually, December 21st, which here in the southern hemisphere is the summer solstice, the longest day, and the sun rises just to the right of the rightmost tower. Then, as the year passes, the sun moves through the towers until on June 21st, which is the winter solstice, the shortest day, it rises just to the left of the leftmost tower. Actually, just in between that mountain, you can see in the distance the leftmost tower. So, at any time of year, if you watch the sun rise, you can measure its position, and you can tell within an accuracy of 2 or 3 days the date. Today's date is September the 15th, and so that means that the sun will rise between the 5th and the 6th towers. Shankio still works as a calendar because the sun still rises in the same place today as it did when these stones were first laid down.
Brian Cox is a wonderful idiot. He's wonderful because he just exposed plate tectonics. And he's an idiot because he's an idiot. He's a round ball guy. Now, he just said the sun rises at the same place as it did thousands of years ago. So he's talking about this place. And this place is called Shankio. and it was built in 300 BC. 2,300 years ago. And he just finished saying that the sun still rises at the same place, remember, as 2,300 years ago. So what happened to plate tectonics? That sun should not rise in the same place due to plate tectonics.
Because the sun still rises in the same place today as it did when these stones were first laid down.
And that's why Brian Cox is a wonderful idiot. And that plate tectonics does not exist.
So we have a lot to learn yet about where faults are.
Scientists have concluded that the melted mantle doesn't blanket areas of the globe enough to be the only thing moving massive plates. They say other factors, such as water and mineral grain size, may be conspiring to aid in plate movement as well. Sorry,
liquid hot magma.
You may no longer get all the credit.
Let me tell you something. Gradual climate change, which is highly accepted today, by the way, does not make fossils. The animal has to be buried rapidly after death, under sediment and then underwater, because you need that extreme pressure and seal to preserve the corpse for fossilization. And then you ask, well, how long does that take? Oh, millions and billions of years. That's what they say. I say, look, if you're smart enough to count that far back, you should be smart enough to give me an exact number, not some relative date. But that's what they do. You think they're laboratory testing everything? At the majority of these digs, they have to report anything that they find, and as a result, you don't always get to see what they find. You know, they find artifacts such as screws and doorknobs in ancient rock. Archaeologists have recently discovered the imprint of a chariot wheel in a deep mine of the Rostov region of Russia, an ancient sandstone that has said to be over 300 million years old. So either the wheel was around 300 million years ago, or that rock is not 300 million years old. By the way, no one will ever know because they flooded the mine. Now I know what you're thinking. And this is a question that comes up all the time. If men, giants, and dinosaurs all existed in Noah's day, and if they were all killed off by the Great Flood, then how come they haven't found any fossils of men from those days? Oh, but they have. But see, they date those human fossils to be hundreds of thousands of years old. Do you know what they do? They use minerals in the dating of these fossils, and if a particular mineral shows that the human fossil is millions of years old, they say, oh no, that's way too old, let's try another mineral. Then the results show that the human fossil is only a few thousand years old. And then they say, oh no, that's too young. They finally get to a mineral that dates the fossil to be around 100 to 300,000 years old. Then they say, oh, that sounds about right. That's what they do. Now in the Bible, in the books of Joshua and Samuel, there is mention of the book of Jasher, the book of the upright. Now they say that this book was lost, but it would have been a canonical work if it still existed. What? So they're saying that a canonical book was lost? How many other canonical works were lost? Would God allow for these works to just disappear? I'm sorry, but that smells fishy to me. What's interesting is that there is a work of fiction called the Book of Jasher, and in it are also accounts of the Great Flood. And it states that the righteous men who knew God lived out their lives and died before they would have to witness the flood. In other words, the only ones who were around to be killed by the flood were the Nephilim, their monsters, and whatever evil men that were still left lurking around at that time. Remember, folks, more than half the planet is covered in water. How many archaeological teams do you see digging up the bottom of the ocean? Look, people are entertained by the idea of fallen angels being locked up in Antarctica. I don't know anything about any fallen angels being bound in Antarctica. There were 200, and for all we know, they could be everywhere. I will say this. One of the worst places on the planet to be right now is right along the river Euphrates. Biblical texts state that 4 of the fallen angels were bound underneath the Euphrates River. Turkey, Syria, Iraq, Iran, Kuwait, Saudi Arabia, the United Arab Emirates. There is apparently a lot of oil there, which means there was and is a lot of death there. Should it surprise you? It may have been the best place on earth at one time, but you can't imagine the amount of horror stories that come out of this region. The anomalies. Go read up on the Gate of Hell in Turkey. There are places like this around the world. How many of you know of the 14,000 meter deep well in Siberia? A hole that was dug back in the late 1980s. After taking temperature readings of the bottom of this well, they discovered the temperature was an astounding 2,000 degrees Fahrenheit. Not only that, but they sent down audio recording equipment to record the sounds of tectonic plate movement, but instead, they recorded what sounded like human voices screaming in agony. Listen. Interestingly enough, the scientists also reported witnessing a luminous gas rising out of the hole, and out of this cloud appeared a winged humanoid being. Needless to say, half the scientists quit working on the project.
Time to throw out some of your old middle school geography textbooks.